We're going to start with simple equations, and we're going to be doing single step in the next 2 days. First, we're going to look at single step addition. So you will see a plus sign in the following problems. Okay? Single step addition equations. All right, so that means there's going to be one step in order to solve each of these equations. And since it's going to have a plus sign, we need to do the opposite of that, which is subtract. And what is the name of the property we talked about? Inverse what? Inverse operation of addition. Yes. The reason we learn that is because if you subtract something after you add it, you end up with the same thing back. And we're going to be solving for the variable. So let's get right to it. Let's look at the first example. And they're going to get harder as we go on. Let's do x plus 17 equals 31. Okay, so actually there are a couple of properties we're using for this particular example. So step one, make sure you write it down at least once. It says subtract the constant on the variable side to both sides. So there are two constants in this equation, but there's only one constant on the variable side, meaning on the same side of the equation as the variable, and that's the 17. So the two properties that we're using, we are going to subtract 17 from both sides. So the first property you guys said was inverse operation of addition. But what property allows us to subtract the same number from both sides? That's what we just went over last week. No? Yeah, good. Property, it's the subtraction property of equality. So we're using both of those properties. So if we subtract 17 from both sides, the equation will remain equal, just like we looked at with those scales. So anyway, when you do this, sometimes people put a slash through plus and minus. That helps some people. And now all we have to do is do 31 minus 17. Good, equals 14. So step two is to simplify. Make sure you write that down. So in other words, 31 minus 17 equals 14. Now there is a third step that you can do. Does anybody know how you would check your work? Okay, good. So what you would do is you would rewrite the equation and you would plug in what you got for x. And what I like to do, I'll scroll up in just a second. What I like to do is put a question mark here and see, does that make sense, my answer? And if we add them up, we get 31. And yes, it totally makes sense. And there we go. That's what we had right there. Example 2. All right, and so what we're going to do a couple different things here. It's going to look a little different, but the steps are the same. 3/4. It's still going to be a single step plus x equals 2/3. Okay, now we know it's a single step because there's only one x, okay, and it's addition, and yeah, that's pretty much it. There's no coefficient for the x, which we'll talk about later, but it's still single step. We're still going to subtract the constant on the variable side to both sides. Yes?
First, you find the common denominator?
Yeah. Okay, so but what are you going to subtract from both sides? That's my question. Yeah, you're going to subtract the same number. We're going to subtract the same number on the x from both sides. So what's different is the number on this one comes first before the x, and that's okay. You're still following that same step. You're going to subtract the constant from both. I should say from. I'm kind of a stickler for grammar here. You subtract from and you add to. Fix that real quick. Okay. So the way this is going to be set up, and I'm not going to simplify it just yet. I'm just going to rewrite what I have just so you guys are clear. It's going to be x equals 2/3 minus 3/4. Right? So what were you saying about common denominator?
Like you we can multiply the 3/4 to
What's the common denominator between 3 and 4?
12.
12, okay? So what do we need to multiply the 3/4 by? No. How does the 3 become a 12? Yes, you multiply it by 4. You're multiplying it by this denominator, and then the other fraction, you're going to be multiplying by that denominator. So it's going to be minus 3/4 times 3/3. No, it does not. That's a good guess, but no, cross-canceling does not work here. So the left fraction is going to become 8/12. The right fraction is going to become 9/12. And then it's easy because all you have to do is add or subtract straight across. So the answer is -1, 8 minus 9/12. Okay, I'm not going to check my work this time. I am going to check it, but I'm not going to plug it back in. I'm just going to go back and make sure that I didn't make any mistakes. 3 times 3 is 9, 2 times 4 is 8. This one's going to be a little tedious to plug back in, but it will work. You'll end up with 3/4 minus, you end up with the 12/4 minus, what am I saying? 9/12 minus 1/12 is 8/12, which reduces to 2/3. But anyways, you just subtract it from both sides, and in this case, you simplify the fraction. Any questions about that? All right, now what if it looks like this? I'm going to do a decimal this time. 2.3 equals x plus 7.7. All right, so difference here is x this time is on the right side of the equation. We're going to look at some also. It doesn't have to be x, okay? It can be a or b or y or any letter really, except for e and pi and I. Those are special, right? But for the most part, it can be any variable. But this time the variable's on the right. Now it doesn't matter, guys, if the variable's on the left or right. We're going to use a third property for this question. So anyway, the first thing we're going to do is subtract the constant from both sides of the equation. And so what would that be? The 7.7, that's right. So we're going to do minus 7.7 on that side, minus 7.7 on that. Now, 2.3 minus 7.7, I'm going to give you a hint. It's not 10. That would be adding. And it's not negative 10 either. Yes.
5.4.
Okay, with a what in front? Yeah, right. If we added 7.7 to 5.4, it'd be 2.3, and so therefore when we subtract it, that's correct. Good job. So in this case, we see that x is negative. Doesn't matter, not really. I mean, we solved it out and we got an answer. X can be negative. If you wanted to check your work and plug it back in, you'd have 7.7 plus negative 5.4, which is subtraction. I'd give you a positive 2.3. Now, if we wanted to reverse it, a lot of times people like to put x on the left. You can. What property lets us switch the equation like that? This was way back from like day 1 or 2. Reflexive property. Yep, a number is equal to itself. Actually, it is symmetric. You're right. I'm sorry. Reflexive just is a number is equal to itself. Symmetric means you can flip it. That's right. Good job. Okay, next example. We'll make it a little bit, I guess you could say harder, but not really. We're going to do a plus negative e equals e. So let me ask you first of all, which one is the variable?
A.
A, right? E is a constant number. Now second of all, guys, now what does the first step say? It says to subtract the variable from both sides. Okay, you do add it, but we are going to subtract the actual constant So we can actually subtract the negative e from both sides because that is the constant. Now you do end up adding it, but you still, if it's being, I know it's a negative being added, right? But you're still doing the opposite of that. So you're still subtracting. But you're right, ultimately it will be adding. Okay, so I'm going to rewrite this. It's going to be e minus negative e, which becomes what? A equals e plus e. Yes. Remember that, if there's no coefficient, you can put a 1 there. And 1e plus 1e is 2e. So what I want you to get from this is, yes, it is adding a negative, but you're still subtracting the actual number from both sides, which ultimately ends up being added, which kind of is going to lead us to the next lesson. I want to do one more, which you probably won't see on the worksheet, but nevertheless, I try to throw in a lot of different examples. We're going to do the square root of 7 plus y equals 2. So let me ask you guys this. What would you subtract from both sides? Good. So the square root of 7 is a constant number. We're going to subtract it from both sides to solve for y. All these, by the way, should have directions. They should say solve. But anyways, you guys know the difference between variables and constants, but all of these that we're doing, the directions, especially in the worksheet, will say solve. So let's just rewrite this one. We're going to have y equals 2 minus radical 7. What else can you do at this point? There's actually nothing. It was a trick question. You cannot combine a square root with a regular number, a rational number. So you literally have to leave it that way.
I was saying find out
The decimal?
Yeah.
Nope. Nope. You want it as accurate as possible, and so you want to leave the square root like it is. Okay? Any questions on this lesson? Pretty simple. Actually, there is one more I want to do. I just noticed something here. Not terribly important, but we'll go ahead and do it. Okay, so let's say we have negative 4 equals z. Actually, let's do negative 2 plus z. So what would you be subtracting this time? It's going to kind of lead us to the next example. What would you be subtracting this time?
2.
Yeah, we're going to be subtracting the negative 2. Now this is leading us to the next lesson because it's easier just to add it. But technically it is adding to the z, and so we're going to go ahead and follow through with the steps. Again, it's a lot easier if you just add it, but you guys can already see that. Whoops. So on the left, I'm going to have negative 4. I have to erase that. Negative 4 minus negative 2 equals, and since we subtracted it, it will cancel z. Now, you just pointed out that negative 4 minus negative 2 is the same as negative 4 plus 2. And what is negative 4 plus 2? Negative 2. Okay, so that's it for that. Leads us to the next lesson, which is single step subtraction.